Hello aspirants. So in this short video, we'll try to understand quantum computers. Why this quantum computers topic is very important for prelims this year? It is because there are many news items related to this quantum computers. So very recently government gave approval or it released 6,000 crores of rupees in the national mission of quantum technology and application. And a few years back, if you remember, in 2019, Google has built a quantum computer known as Sycamore, and it claimed that it achieved quantum supremacy. So what is quantum supremacy? It is an idea which says that the quantum computers are much faster than compared to even the best of the supercomputers. So Google said that its quantum computer Sycamore was able to do a calculation which even the fastest supercomputers would have taken 10,000s of years. So Google took only, or Google's computer, this quantum computer just took 200 seconds. However, this claim was refuted by IBM. So IBM is another pioneer in quantum computing. So they said that their supercomputer was able to solve this particular piece of problem in just 2.5 days. So this quantum computing technology keeps coming in the news. That is why it is important for us to know it. Last year also there was one question in prelims. So what are qubits? So that was a very basic question with respect to quantum computing, and now you can expect from UPSC that a higher level question can be formed from this topic. So let us just try to understand how are quantum computers significantly, or we say that it is fundamentally different than the conventional computers that we have. The conventional computers that we use, it uses what is known as binary digits. It uses binary digits. It uses binary digits, which is also called as bits. So your bits are your 0 and 1. So the conventional computers, they understand the language of only zeros and 1. Even if you give a simple calculation like 7 plus 10, how much is 7 plus 10? It does not understand what is 7, it does not understand what is 10. It will first convert 7 into some string of zeros and 1, into some combination of zeros and 1. So let us say this combination of 0 and 1, another combination of zeros. So it will convert it into some combination of zeros and 1, then it will do the processing in zeros and 1 only, then it will convert into our language. So this language that the computers use, this is known as machine language. So computers understand this type of language. So the conventional computers are using bits, that is zeros and ones. But what is the problem with zeros and ones now is that we have reached the fundamental limit with respect to the processing power or the speed of processing. So in order to produce zeros and ones, what do our computers do, or what do the computer have that produces these zeros and 1? So you would know that our computers, the main part of the computer is your central processing unit. So the main part of the computer, or the brain of the computer, is called as central processing unit. So what is inside the central processing unit? So inside the central processing unit, you will see a chip. So you would have seen there is an Intel chip, or there is an Apple chip, Apple M1 chip. So what is inside this chip? So the chip has this processing power. So how do these chips work? So these chips have what are known as some small switches. These are very small switches. These switches on the chip, they produce 0 and 1. Every switch that you see, so it has the capacity to produce 0 and 1. So these small switches or micro or mini switches are called as your transistors. So these are called as your transistors. So how does this function? How does it produce 0 and 1? So if you think that 1 is passing of electron, if this transistor or this switch, if allows or it passing of electron, that is 1, then when it stops the electron, so that would be considered as 0. So, if this switch allows to pass an electron, it will produce 1. If it does not allow to pass an electron, it will produce 0. So, this is how, when so many transistors, so many switches, they act together, they produce these strings of zeros and ones or arrays of zeros and ones, and then they do the processing, and after that they can retrieve also, they can store the data, but essentially they are using these transistors, or they are using this zeros and ones to do the calculation. So, this is known as binary digits. But what is happening, that now the chips that we have, initially on chips there were some transistors, but with development what we are seeing, the size of these transistors have started decreasing. So, they have become smaller and smaller, and nowadays you can even produce a chip, or in a chip you will have a transistor of the size of 2-3 nanometers. So, we cannot build a transistor smaller than this 2-3 nanometer size. Because of that, we will not be able to make some computers which are phenomenally faster than what we already have. So, this is the peak of the conventional computers that we have reached. So, there is a talk that how do we get a computer which is faster than even the supercomputers that we have. So, the idea here is that we will need to use some different principle altogether to build computers. So, here we are utilizing the principle of quantum physics. So, in quantum computers, so what is this word? This word comes from quantum physics. So, what is quantum physics essentially? Quantum physics is the physics, it is a sub branch of physics which deals with atoms and subatomic particles. So, it will deal with, let us say, electrons, it will deal with protons. So, it will deal with what is inside a nucleus. So, it will try to understand the structure of a nucleus. So, we are utilizing some principle of quantum physics to build this type of quantum computers. So, here because we are using a fundamentally different process, that is why the computers that we will be building is fundamentally different from the conventional computers. So, here we are using not normal bits, but here we will be using what is known as qubits or quantum bits. How do we understand this quantum bit? So, if you take 0 and 1, if you take 0 and 1 as two sides of a coin, then if you flip the coin, and at the end you will get either head or tail, or at the end you either get 0 or 1. So, here you are getting one of the two positions, that is either 0 or either 1. So, this is the normal bit. That what can be a qubit then? What is a qubit then? So, imagine in this example that you have a coin with 0 and 1 on both the sides, or on that we are saying that on one side you have 0 and on the other side you have 1. So, instead of flipping the coin, what we are doing, we are spinning the coin. When we spin the coin, so if we keep the coin and if we spin the coin, now when we look at the coin when it is spinning, we cannot say that either it is 0 or whether it is 1, or we can say that it is at both the position, it is at both 0 and 1 also, or we can say in probability at the max that it is 50% 0 or it is 50% 1. So, this type of state of this 0 and 1 is called as superposition, and this is what is known as qubit. So, this qubit is actually superposition of 0 and 1. So, qubit is superposition of 0 and 1. Superposition, it is a concept of quantum physics. How do we understand, let us say, a bit more about superposition? To understand superposition, sometimes it becomes difficult to imagine or visualize. So, there are many corollaries given to understand this superposition. So, one of the corollaries that is given is this example of a box in which there is a cat. So, inside a box you have a cat and you have kept a venom or a poison, and now this box this box is closed. So what we are doing here is that we are keeping a cat inside a black box, and we have also placed a venom or a poison. So if the cat drinks the venom, it will die. So if we are looking at the black box now, when the box is closed, can you tell what is the state of the cat, whether it is alive or whether it is dead? So we cannot tell with some definiteness that whether it is alive or dead. Only when you open the box can you tell whether the cat is alive or dead. But when the box is closed, you can say that it is both alive and dead, or you can say that it is 50% alive and 50% dead. That is the idea of superposition. So even in this case, in zeros and ones, so what you are seeing that the transistors, they produce either 0 or 1. They are not producing states in between them. They are not producing states in between them, and because of that there is a limitation. In quantum computer, it is like they are producing many things in between 0 and 1. So there are like many parallel conventional computers working together, and because of that the strings that can be produced of zeros and ones is much larger, and that is why the processing power is much larger and storage power is much larger compared to your conventional computers. So this is the idea of superposition. So how do we get superposition? To get a superposition, it is a difficult task. So we are trying to use some method to get this superposition. How do we get zeros and one in conventional computers? So we use semiconductors. These semiconductors allow the electron to pass or not to pass. So one of the idea is, with respect to how do we get a superposition or how do we get a qubit, is by utilizing either photons or by utilizing the spin of an electron. So an electron in its orbit or in its shell, it keeps on spinning. It can spin clockwise or it can spin anti-clockwise. But when you try to look at an electron, you cannot actually tell that whether it is spinning clockwise or it is spinning anti-clockwise, or you cannot tell what type of spin it is having. So you can say that at best is that it has all the kinds of spins, or it has all the positions that is possible for an electron. Why we cannot tell the spin of an electron? So another problem with our physics is that, let us say you have an electron here and you want to see where is this electron, or how this electron looks like, or how is it spinning. So how can we see an electron? If we want to see an electron, we will have to throw some light, and that light must reflect back to our eyes, then only we can see it. So light must reflect back and reach here. But when we throw a light to see an electron, the light itself will displace the electron. So you cannot see the electron actually there. So if you throw light, the electron will get displaced off. So you cannot tell what is the direction of the spin. So we can utilize this concept. So this concept is known as superposition. It utilizes another concept which is known as quantum entanglement. So this is, let us take one qubit. One qubit is the coin is spinning. So this is your one qubit, and let us take another qubit, and this is also spinning. So when you say quantum entanglement, what do you mean by quantum entanglement? In this case is that the state of one determines the state of other, or if you know the state of this, you can know the state of this. That is, they are interrelated with each other. That is the uniqueness of quantum entanglement, and we are utilizing these properties to build quantum computers. So the pioneers in building quantum computers are obviously Google and IBM. So quantum computers, the design of quantum computers is very unique. So it doesn't look like our conventional computers. So they look much like chandeliers. I'll just show you an image of quantum computers. So you can identify this person. So this is a quantum computer, and can you see it is unlike our traditional PCs or computers that we know. So it has a design of a chandelier. It looks like a chandelier. So what do you have? The qubit. The qubit is placed here, or it is generated here, and in order for the qubit to function here, you need what? You need very low temperature. These qubits, because they are in superposition, they are very fragile. So in order to protect it from any interference, they are kept inside metal containers, and they are kept at very low temperatures, which is reaching to cryo temperature. When you say cryo temperature, any temperature which is below minus 150 degrees Celsius is called as, or it is referred to as, cryo state. So they are kept, we are trying to keep it at very low temperatures. So here is your qubit and all these layers are just trying to keep the subsequent layer cooler and cooler. So this layer is the coldest one. So this is essentially the design of quantum computers. So because you can see that because there is the limitation with respect to the structure and the design, there are many challenges of quantum computers. But what are the potential applications of quantum computers? Why is the world so much interested in quantum computers? Why has the government of India started the national mission on quantum technology and application? Government in budget of 2021, it had allocated 8,000 crores of rupees for this mission. So India do not want to lag behind or do not want to miss the bus. So India is also investing in this technology. So what is the benefit, or what are the potential application areas of quantum computers? So there are many application areas of quantum computers. One of the major application areas, if you listen to IBM's quantum computer chief, he says that we do not understand the molecular level interactions of some of the compounds. He gives an example of coffee and water. If you mix coffee in water, we do not know the exact pattern of how coffee molecules is interacting with water molecules. So even supercomputers might not be able to decipher it, but a quantum computer might be able to decipher it. So because we can know the molecular level interaction, then it is possible that we are able to develop new materials, the materials which have not existed till now. We can even make drugs, some medicines which have not been built till now. So that is the major application area of quantum computers. Other area is like in weather forecasting. Weather is a very complicated and sophisticated phenomena. So predicting weather is a very big challenge. It is a big mathematical modeling problem. So how do we model this weather forecasting better? So if we have this type of quantum computers, then we will be better able to develop these type of models which can go for weather forecasting. Another application area is in optimizing the supply chain. So as the supply chain, as the economies are growing across the globe, so supply of goods is increasing, but we need to optimize the supply. So if you look at the fleet of ships, there would be hundreds or there would be thousands of ships which are carrying thousands of resources or thousands of materials from 1,000 points and reaching to thousands of destinations, and they are carrying through different routes across the year. If we want to optimize this, this optimization modeling, the number that we come up with, it becomes larger than the total number of atoms. So even optimizing these ship fleets is a challenge. So we are not able to do it with supercomputers. So we need very powerful computers. So in that case, we can use quantum computers. That is the biggest advantage of this. Another potential application area is obviously in the financial field. So in financial field, so it can help in making better investment decisions. So global risks could be incorporated while your fund manager takes a decision. We can build very powerful trading platforms where these new emerging assets like cryptocurrency or your NFT can be traded. So these are the potential areas. Another major application of quantum computer could be in AI. So AI is also in news. ChatGPT that you are hearing about is one of the facets of AI. So if we want to make AI systems very powerful, how do we make AI systems very powerful? Only by training it more, training by more complicated and sophisticated data, more data. So quantum computers can make different facets of AI very, very powerful when the data processing requirement is very high. For example, if you have to process videos, if you have to process images, in that case quantum computers can be very, very helpful. So this is also one of the major application area that it can make AI system very powerful. Another application area is in quantum communication. So nowadays communication that we are following. So we are using internet to communicate. Internet is an open network and there is always concern with respect to hacking or data leakage or concerns of data privacy. So we need to develop more secure systems of communication via the internet. So we are trying to find some ways to make the communication secure. So we have started using this encryption method. What is encryption? Encryption means you are hiding the real data by using some complex mathematical algorithms. So you are using some problems to hide the data. So the solution to that problem is with the sender and the receiver only. So anybody in between cannot intervene in between and can read that data. But still we are seeing that data hacking is possible using this method. So sometimes this key is hacked by some of the hackers and we are not able to trace whether this communication is secure or not, whether it was hacked in between or not while it was being sent from the sender and the receiver. So here we will be using quantum communication technology or what is known as quantum key distribution. What is quantum key distribution? So we will have the original message and we will develop something as a mathematical problem and then we will make the key using this superposition. So the key will be in superposition state. So the key would be with the sender and the receiver only, and if anybody intervenes in between, because the key is in superposition state or it is in quantum state, so if anybody intervenes then a trail will be left that somebody has intervened this communication channel. So we can come to know that if our data was breached in between or not. So this is also a developing phenomena with respect to quantum technology. Then there are other potential application areas like in agriculture, in health and education. So these are some of the major application areas of quantum computing. But what are the challenges of quantum computing? The challenges are also immense with respect to quantum computing. So the major challenge here is that the qubits are very, very fragile. So you need to protect it from interference. So any type of interference, it can damage the calculation. So your quantum computing can be lost if there is any disturbance. And because these qubits are very fragile, if you want to combine many qubits together, that is also a challenge. So we are able to develop or we are able to combine a few dozens of qubits only, but if you want to combine, let us say, hundreds and thousands of qubits together, then that will be very, very sophisticated technology. So that is a challenge that we need to address. Another concern is that we need this intensive cooling system is required, and another problem that it faces is that the conventional computers, they use what is known as error correction algorithm. So we know that conventional computers, they produce errors, but we somehow have methods to resolve these errors. But in quantum computers, we do not have, or we haven't developed any algorithm which can go for error correction. Then compared to or coming to India, what are the problems? So these technologies are very sophisticated. We do not have the infrastructure. There is poor support as of now. Government has started now only. There is no private sector enthusiasm in this. There is low awareness among people and even among businesses. So this technology is, yes, it is the future of quantum or future of computing, but we need to generate more awareness among Indians also. And with that, if any more news comes with quantum computing, we will come again. So thank you for this small video.